On November 24, 1944, at 0830 hours, Lieutenant General Haywood Hansell stood on the control tower at North Field, Saipan, watching the first Boeing B-29 Superfortress lift off for Tokyo. The aircraft climbing into the morning sky represented the culmination of $3 billion, 4 years of engineering, and America's single largest military investment of the war. Larger than the Manhattan Project, larger than any naval construction program, larger than anything. Hansell had received intelligence reports from Japanese sources 2 weeks earlier through decoded radio intercepts. Japanese military analysts estimated that American B-29 production capacity could not possibly exceed 200 aircraft total, maybe 250 at absolute maximum. The numbers seemed logical to them. They had studied American bomber production. They understood aircraft manufacturing timelines. They knew the B-29 was the most complex aircraft ever built, but standing on that tower, Hansell knew something the Japanese didn't. By the time the first B-29 reached Tokyo that afternoon, American factories had already delivered over 500 Superfortresses. Production was accelerating, and the Japanese estimate of 200 aircraft maximum wasn't just wrong, it was catastrophically wrong. By war's end, America would build 3,970 B-29 seconds, nearly 4,000 of the most advanced bombers in history. The question that would haunt Japanese military planners for the next 8 months was simple. How did we get the numbers so wrong? And more importantly, how do you defend against an enemy who can produce aircraft faster than you can shoot them down? If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Japan entered 1944 with a clear understanding of American bomber capabilities. They had faced B-17 Flying Fortresses and B-24 Liberators in the Pacific. They knew these aircraft. They understood their ranges, their bomb loads, their vulnerabilities. Japanese air defense doctrine was built around intercepting formations of these medium-range bombers. The B-29 changed everything. The specifications alone seemed impossible. Maximum speed, 357 miles per hour. Service ceiling, 31,850 feet. Range, 3,250 miles, fully loaded. Bomb load, 20,000 pounds. These numbers meant the B-29 could fly higher than most Japanese fighters could climb, faster than most Japanese interceptors could catch, and farther than any bomber previously deployed in the Pacific. But specifications on paper were just numbers. The real shock came when Japanese intelligence agencies began receiving reports about American B-29 deployment in mid-1944. The first reports came from agents in China. American Superfortresses were arriving at airbases around Chengdu, not dozens, hundreds. The agents counted aircraft, photographed them, reported the tail numbers. Every report confirmed more B-29 seconds than Japanese analysts thought possible. In Tokyo, the General Defense Command reviewed these intelligence reports with increasing concern. Major General Torashiro Kawabe, Deputy Chief of the Army General Staff, assembled a working group in April 1944 to assess the B-29 threat. The group's task was straightforward: determine how many B-29 seconds America could produce, calculate when they would begin operations against Japan, and develop countermeasures. The working group started with public information. American newspapers and trade publications had been reporting on B-29 development since 1942. The Boeing company had announced contracts, construction timelines, factory locations. None of this was classified. The Americans made no secret of the B-29 program. In fact, they publicized it. President Roosevelt himself had mentioned the Superfortress in speeches. Kawabe's analysts compiled data on American aircraft production capacity. They knew Boeing had facilities in Seattle and Wichita. They knew Bell Aircraft was building B-29 seconds in Marietta, Georgia. They knew Martin had a plant in Omaha, Nebraska. They even knew approximate workforce sizes at each facility. The intelligence was good. The analysis that followed was completely wrong. The working group calculated maximum B-29 production using Japanese manufacturing assumptions. A B-29 contained 40,540 different parts. It required 600,000 rivets. The engines alone were the most powerful piston engines ever mass-produced, 18-cylinder Wright R3350 duplex cyclones, producing 2,200 horsepower each. 4 engines per aircraft meant 8,800 horsepower per Superfortress. Japanese analysts knew their own aircraft. Industry. Japan's most modern bomber factories could produce perhaps 20 aircraft per month at absolute maximum capacity. That was with experienced workers, established supply chains, and simplified designs. The B-29 was exponentially more complex than anything in Japanese production. It featured the first fully pressurized bomber fuselage in history. It had remote-controlled gun turrets linked to an analog fire control computer. It used advanced radar systems. Every system represented cutting-edge technology that required specialized manufacturing. The working group concluded that American B-29 production capacity could not exceed 150 to 200 aircraft per year, maybe 250 if the Americans dedicated massive resources and accepted quality compromises. The math seemed solid. Building complex aircraft took time. Training workers took time. Establishing supply chains took time. Even with America's larger industrial base, there were physical limits to how fast aircraft could be produced. This estimate was presented to the Imperial General Headquarters in May 1944. Senior officers accepted it without question. The numbers matched their understanding of aircraft manufacturing. The assessment seemed conservative and realistic. Japanese military planners began developing air defense strategies based on facing approximately 200 B-29 seconds total, with perhaps 100 operational at any given time. They were wrong by a factor of 20. The first B-29 combat mission launched from India on June 5, 1944. 77 Superfortresses attacked railway facilities in Bangkok, Thailand. Japanese observers noted the number. 77 aircraft in a single raid. That was already more than half the total number Japanese intelligence estimated would ever be deployed. 10 days later, 68 B-29 seconds bombed the Imperial Iron and Steel Works at Yawata, Japan. This was the first American air attack on the Japanese home islands since the Doolittle Raid in April 1942. The raid caused minimal damage, but it revealed something terrifying to Japanese air defense commanders. The Americans had enough B-29 seconds to conduct raids on Japan while simultaneously maintaining bomber forces in other theaters. Japanese fighter pilots who engaged the B-29 seconds over Yawata reported aircraft flying at altitudes between 28,000 and 32,000 feet. Japanese fighters struggled to reach those altitudes. The Mitsubishi, a 6M0, Japan's primary fighter, had a service ceiling of 33,000 feet, but at that altitude it could barely maneuver. The Nakajima Ki-44 Shoki could reach 36,000 feet, but only a few hundred were in service by mid-1944. More critically, at high altitude, Japanese fighters lost speed and maneuverability. The B-29 seconds, flying in formation with interlocking fields of defensive fire from their remote gun turrets, proved nearly impossible to intercept effectively. Japanese pilots reported that the Superfortresses maintained formation discipline even under attack, that their defensive armament was devastating at close range, and that the bombers seemed to absorb battle damage that would destroy any Japanese aircraft. The Yawata raid cost Japan 2 B-29 seconds shot down and 5 more lost to accidents or mechanical failure. 7 aircraft lost out of 68 attacking. That was roughly a 10% loss rate. Japanese commanders considered this acceptable. If every raid cost the Americans 10% of their force, and if America only had 200 B-29 seconds total, attrition would ground the entire force within months. But the raids continued, and the numbers kept increasing. In July, 80 B-29 seconds attacked targets in Manchuria. In August, 70 B-29 seconds hit Yawata again. In September, 108 B-29 seconds struck Anshan Steel Works. Each raid included more aircraft than the previous one. Japanese. Intelligence officers in China counted aircraft at American air bases. The numbers didn't make sense. Bases that had held 70 B-29 seconds in June now held 90 in August. New aircraft were arriving constantly, replacing losses and expanding the force. By October 1944, Japanese estimates of American B-29 strength had been revised upward to 400 aircraft. This figure still seemed impossibly high to senior officers in Tokyo, but reconnaissance photographs confirmed it. American airfields in the Mariana Islands were under construction, and each field was designed to hold 4 bombardment groups of 45 aircraft each. 5 airfields, 900 aircraft. The mathematics of this discovery were staggering. If the Americans were building airfields for 900 B-29 seconds in the Marianas, they must be producing far more than 200 aircraft total. But how? Where were these aircraft coming from? Japanese intelligence reviewed American factory capacity again, looking for evidence of expanded production. What they found should have terrified them, but the scale was so large they couldn't fully process it. Boeing's Wichita plant was producing B-29 seconds at a rate of over 100 per month by late 1944. Boeing Renton was adding another 30 per month. Bell Marietta was producing approximately 20 per month. Martin Omaha was contributing 15 per month. Total American B-29 production, approximately 170 aircraft monthly, 170 B-29 seconds per month. The Japanese had estimated 200 aircraft per year. The Americans were building nearly that many every 5 weeks. Lieutenant General Kawabe received updated intelligence reports in November 1944. He read them 3 times, certain there had been a translation error or a miscalculation. American B-29 production was exceeding 4 bomber groups per month. That meant the United States was producing more Superfortresses in a single month than Japan's entire heavy bomber force. The implications were devastating. Even if Japanese air defenses shot down 50 B-29 seconds every month, an impossible achievement, American factories would replace them and add another 120 aircraft to the force. The mathematics of attrition warfare only worked if you could destroy aircraft faster than the enemy could produce them. Against B-29 production rates, Japanese air defenses couldn't win. They could only delay. In December 1944, the American 20th Air Force began operations from the Mariana Islands. The first raid from Saipan launched on November 24th, with 111 B-29 seconds attacking Tokyo. Japanese air defenses shot down only 1 aircraft, 1 loss out of 111, less than 1%. The raid itself caused minimal damage. High-altitude winds over Tokyo reached speeds of 200 miles per hour at bombing altitude. These jet stream winds scattered bomb patterns and made precision bombing nearly impossible. But the Japanese understood something more important than bomb damage. The Americans had flown 111 B-29 seconds from bases 1,500 miles away, and this was just the beginning. On January 3, 1945, Major General Curtis LeMay arrived in the Marianas to take command of XXI Bomber Command. LeMay had commanded B-29 operations from China and India. He understood the Superfortresses' capabilities and limitations. He also understood that high-altitude precision bombing wasn't working. LeMay reviewed bombing results from November and December. Most raids had achieved less than 10% of bombs on target. The jet stream was the primary problem. Bombardiers couldn't compensate for winds approaching 250 miles per hour. Aircraft flying at 30,000 feet were essentially shooting at targets through a horizontal hurricane. Even with the advanced Norden bomb sight and radar, accuracy was terrible. LeMay proposed something radical: low-altitude night incendiary attacks. Instead of bombing from 30,000 feet in daylight, B-29 seconds would attack from 5,000 to 7,000 feet at night. They would carry incendiary bombs instead of high explosives, and they would remove most defensive armament to increase bomb load. The proposal seemed insane. Flying at 5,000 feet put B-29 seconds within range of Japanese anti-aircraft guns. Flying at night reduced visibility for both attackers and defenders, but it also made navigation more difficult. Removing defensive guns left aircraft vulnerable to fighter attack. Every tactical doctrine developed for strategic bombing emphasized high altitude, heavy armament, and mutual defensive fire from tight formations. LeMay calculated the risks differently. Japanese night fighters were ineffective. Most Japanese fighter pilots had minimal night flying experience. Japanese airborne radar was primitive compared to American systems. Japanese anti-aircraft guns used visual aiming and time-fused shells. At night, in heavy smoke, accuracy would plummet. The real risk was collisions and navigation errors, not enemy action. More importantly, flying at low altitude meant carrying more bombs. A B-29 flying at 30,000 feet required enormous fuel reserves to reach that altitude with a full bomb load. A B-29 flying at 5,000 feet could carry 7 tons of bombs instead of 4 tons. That was 75% more destructive power per aircraft. On the night of March 9th through 10th, 1945, LeMay launched Operation Meeting House. 334 B-29 seconds took off from Guam, Saipan, and Tinian, bound for Tokyo. 279 aircraft reached the target and dropped 1,665 tons of incendiary bombs on a 3-by-4-mile area of eastern Tokyo. The target zone housed approximately 750,000 people and contained thousands of small factories that were part of Japan's distributed manufacturing network. The raid created a firestorm. Pathfinder aircraft marked the target with incendiaries in the shape of a massive X. Following aircraft bombed the X, winds on the ground reached 45 miles per hour, fanning flames across wood and paper structures that covered most of Tokyo. The fire spread faster than people could run. Temperatures reached 1,800 degrees Fahrenheit. The firestorm consumed 15.8 square miles of Tokyo in under 3 hours. American aircraft flying through the smoke at 7,000 feet experienced violent turbulence from heat updrafts. Crew members reported smelling burning flesh inside pressurized cabins. Some aircraft were thrown hundreds of feet vertically by superheated air currents. Tail gunners reported seeing nothing behind them except a solid mass of fire stretching to the horizon. Japanese casualty figures remain uncertain. The Tokyo Metropolitan Police counted 79,466 bodies recovered. The United States Strategic Bombing Survey estimated 87,793 dead. Some historians place the figure above 100,000. 1 million people lost their homes. 267,000 buildings were destroyed. American losses: 14 B-29 seconds failed to return, and 96 airmen were missing or killed. 14 aircraft lost out of 334 launching. A 4% loss rate. At this exchange ratio, the Americans could bomb Japanese cities indefinitely and never run out of aircraft. Tokyo was only the beginning. Over the next 5 months, B-29 seconds firebombed every major Japanese city. Osaka on March 13th, Nagoya on March 19th, Osaka again on June 1st, Yokohama on May 29th. The pattern repeated across Japan. American bombers appeared over cities at night, flying low, dropping incendiaries, creating firestorms. Japanese air defenses improved, marginally. Fighter pilots developed tactics for night interception. Anti-aircraft crews became more proficient, but the fundamental problem remained. The Americans had too many aircraft. Japanese fighters could shoot down 5 B-29 seconds, 10 B-29 seconds, even 20 B-29 seconds in a single raid. But if 300 bombers attacked, and 20 were lost, that still left 280 aircraft bombing the target, and next week, 300 more B-29 seconds would return because American factories had replaced the losses. By May 1945, Japanese intelligence had finally grasped the scale of American B-29 production. The numbers were no longer estimates. They were observable reality. American bomber formations over Japan regularly exceeded 500 aircraft. On May 25, 1945, 464 B-29 seconds bombed Tokyo in a single raid. 464 aircraft. That was more than twice the number Japanese planners had estimated existed in all of 1944. Lieutenant General Torashiro Kawabe, who had chaired the original assessment committee, reviewed the final intelligence reports in June 1945 He calculated that American B-29 production had exceeded 3,000 aircraft by that point. 3,000. The original estimate had been 200. Kawabe understood what this meant. Japan was not fighting a war against American military skill or American tactical superiority. Japan was fighting American industrial capacity, and industrial capacity was not something that could be defeated through courage, superior training, or warrior spirit. You couldn't sink a factory with a torpedo. You couldn't shoot down an assembly line with a fighter plane. The Americans had built an aircraft so advanced it flew above the reach of most Japanese fighters, so heavily armed it could defend itself effectively, and so capable it could strike targets 1,500 miles from its base. Then they built 4,000 of them. Not 400. 4,000. The number was incomprehensible to military planners who understood aircraft as precision instruments, built one at a time by skilled craftsmen. What Kawabe and Japanese military leadership didn't understand was that America had stopped building aircraft like craftsmen years earlier. They had industrialized bomber production the same way Henry Ford had industrialized automobile production. Assembly lines, standardized parts, modular construction, specialized workers performing repetitive tasks. The B-29 wasn't crafted, it was manufactured. But even understanding this intellectually didn't prepare Japanese commanders for the reality. Because the B-29 wasn't just numerous, it was technologically superior in every measurable way, and that combination, technological superiority multiplied by overwhelming numerical advantage, was something no tactical doctrine could overcome. The story of how America built nearly 4,000 B-29 Superfortresses begins not with Boeing engineers or Army Air Forces planners, but with a decision made in January 1940 that seemed impossibly ambitious at the time. The United States Army Air Corps issued a requirement for a bomber that could fly 400 miles per hour, carry 10 tons of bombs, and operate at a combat radius of 2,500 miles. These specifications exceeded every existing bomber by margins that seemed fantastical. The B-17 Flying Fortress, America's premier heavy bomber, could manage 287 miles per hour maximum speed, carried 4.5 tons of bombs, and had a combat radius of roughly 800 miles. The Army Air Corps was asking for an aircraft that flew 40% faster, carried more than twice the bomb load, and flew 3 times farther than anything currently in production. Defense contractors reviewed the specifications, and several declined to bid. The technical challenges seemed insurmountable. Boeing Aircraft Company submitted a proposal anyway. The company had been building bombers since the 1920s. They understood long-range aircraft design. More importantly, they had already developed pressurized cabin technology for their Model 307 Stratoliner passenger aircraft. That experience gave them a foundation that other manufacturers lacked. On September 6, 1940, Boeing received a contract worth $3.6 million to build 2 experimental prototypes designated XB-29. The contract was modest by wartime standards. The development costs would eventually exceed $9 million before the first aircraft flew. But in September 1940, with war raging in Europe and tensions rising with Japan, the Army Air Corps committed to the most ambitious bomber program in aviation history. The first XB-29 prototype rolled out at Boeing Field in Seattle on September 21, 1942. The aircraft was massive. Wingspan, 141 feet 3 inches. Length, 99 feet. Height, 27 feet 9 inches. Empty weight, 74,500 pounds. Maximum takeoff weight, 135,000 pounds. It was the heaviest bomber ever built, substantially larger than the B-17 or B-24. But size wasn't the revolutionary aspect. The B-29 incorporated technology that had never been integrated into a bomber before. The fuselage featured 3 pressurized compartments connected by a crawl tunnel over the bomb bays. Crew members could operate at 30,000 feet without oxygen masks or heavy cold weather gear. This was standard on passenger airliners, but unprecedented on a military bomber. The defensive armament system used remote-controlled turrets, 4 turrets, 2 on top of the fuselage. Two below were operated by gunners, sitting in pressurized compartments away from the turrets themselves. An analog computer linked sighting stations to gun turrets, allowing any gunner to control any turret. The tail gunner had a dedicated position with twin 50-caliber machine guns and a 20mm cannon. The engines were Wright R3350 duplex Cyclones, the most powerful radial engines in production. Each engine produced 2,200 horsepower. 4 engines meant 8,800 horsepower total. For comparison, a B-17 Flying Fortress had 4 engines producing 1,200 horsepower each, totaling 4,800 horsepower. The B-29 had nearly twice the power, but power came with problems. The R3350 engines were temperamental. They overheated constantly. During early test flights, engines caught fire during takeoff or in flight. The problem was fundamental. The engines produced so much power in such a compact package that cooling was inadequate. Cowl flaps helped but didn't solve the issue completely. Engine fires plagued B-29 operations throughout the war. On February 18, 1943, the second XB-29 prototype was conducting test flights when an engine fire developed. The pilot, Edmund Allen, reported the fire and attempted to return to Boeing Field. 3 miles short of the runway, the fire burned through the wing spar and the wing collapsed. The aircraft crashed into the Fry meatpacking plant, killing all 11 crew members aboard and 18 people on the ground. The crash could have killed the entire B-29 program. Congress questioned whether the aircraft was safe. Critics argued that the technical challenges were too great, that simpler bombers could be produced in larger numbers more quickly, that the B-29 was a waste of resources. But General Henry Arnold, commanding general of the Army Air Forces, committed fully to the program. Arnold understood something that critics didn't. The Pacific War would be decided by range. Japanese-controlled territory extended thousands of miles across the Pacific Ocean. American bombers would need to strike targets deep in the Japanese Empire from bases that might be hundreds or thousands of miles away. No existing bomber had that capability. The B-29 did. Without the Superfortress, the strategic bombing campaign against Japan would be impossible. In May 1941, even before the first prototype flew, the Army Air Forces had ordered 500 B-29 seconds. This was extraordinary. Ordering production aircraft before the prototype was tested violated every normal procurement procedure. But Arnold knew development would take years. Waiting for testing to be completed before ordering production aircraft would delay deployment until 1945 or later. Arnold wanted B-29 seconds in combat by mid-1944. The production order required building factories specifically designed for B-29 manufacture. Boeing's existing facilities in Seattle and Renton, Washington, would be insufficient. New plants were needed in locations safe from potential enemy attack and close to transportation. Networks. Boeing built a massive facility in Wichita, Kansas. The plant covered hundreds of acres and employed over 30,000 workers at peak production. Bell Aircraft built a plant in Marietta, Georgia, near Atlanta. The Bell Marietta facility was specifically designed for B-29 production from the ground up. Glenn L. Martin Company built a plant in Omaha, Nebraska, converting existing facilities used for B-26 Marauder production. These 3 plants, plus Boeing's Renton facility, would produce all B-29 Superfortresses built during World War II. But building factories was only the first challenge. Boeing then had to solve the problem of how to actually build B-29 seconds at industrial scale. Traditional aircraft construction relied on skilled craftsmen, workers who understood aircraft structures, who could read complex blueprints, who could custom-fit parts that didn't quite match specifications. These craftsmen were masters of their trade, but they worked slowly, and there weren't enough of them. Training a skilled aircraft worker took months or years. America didn't have that time. Boeing's solution borrowed from automobile manufacturing. Break the aircraft into major subassemblies. Build each subassembly on its own production line. Use standardized parts manufactured to precise tolerances so they fit without custom work. Train workers to perform specific repetitive tasks rather than requiring them to understand the entire aircraft. Then bring the sub-assemblies together for final assembly. Oliver West, Boeing's production engineer at Wichita, developed a system called multi-lining. Instead of a single assembly line that built aircraft from front to back, West created 6 parallel lines that built different sections simultaneously. Wing sections, fuselage sections, and tail assemblies were constructed on separate lines. These major assemblies converged at 3 final assembly positions, where the complete aircraft came together. The system allowed Boeing to increase production dramatically without requiring massive single buildings. It also meant problems in one assembly line didn't shut down the entire factory. If wing production had issues, fuselage and tail sections continued. Parts could be stockpiled and assembly balanced across the 3 final positions. But the real revolution was in parts standardization. Every B-29 used identical components. Every rivet was the same size and type. Every hydraulic line was built to identical specifications. Every electrical connector matched exactly. This meant parts could be manufactured at specialized facilities across the country, shipped to assembly plants, and installed without modification. A B-29 required 12 tons of aluminum sheeting, over 1,000 pounds of copper, 600,000 rivets, approximately 9 miles of electrical wiring, and 2 miles of tubing. Every single component had to meet military specifications. Tolerances were measured in thousandths of an inch. A rivet, hole that was a few thousandths too large or too small, would be rejected. Quality control was absolute. Army Air Forces inspectors stationed at every factory checked components at multiple stages of production. Aluminum skin panels were inspected. Wing spars were X-rayed for cracks. Engine mounts were stress-tested. Hydraulic systems were pressure-tested. Electrical systems were tested under load. Nothing was assumed. Everything was verified. This level of quality control slowed production initially. The first B-29 seconds took over 150,000 man-hours each to build. Experienced workers, many problems, constant modifications, as engineers refined the design. But Boeing learned from each aircraft. By studying where workers spent time, where mistakes occurred, where bottlenecks developed, production engineers redesigned workflows and tooling. By 1944, Boeing Wichita had reduced production time to under 20,000 man-hours per aircraft. They had cut construction time by 85% through workflow optimization, better tooling, and worker training. At peak production in late 1944, Wichita was completing over 4 B-29 seconds per day, 4 complete bombers every 24 hours. The workforce at Wichita peaked at over 30,000 employees. At Bell Marietta, employment reached 28,000. At Martin Omaha, 15,000 workers. Boeing Renton added thousands more. Total employment across all B-29 production facilities exceeded 80,000 people. These workers were not traditional aircraft craftsmen. Most had never touched an airplane before 1942. Many were women who had been teachers, retail clerks, housewives before the war. Many were African Americans who had been excluded from industrial employment in peacetime. Boeing hired them, trained them, and put them to work building the most complex aircraft in the world. Training programs condensed years of apprenticeship into weeks or months. Workers learned to rivet aluminum skin panels. They learned to install hydraulic lines. They learned to wire electrical systems. Each worker specialized in specific tasks, performed repeatedly. A riveter might install thousands of identical rivets in identical locations across dozens of aircraft. The repetition built speed and precision. The factories operated around the clock in 3 shifts. First shift built sub-assemblies. Second shift continued assembly work and performed installations. Third shift conducted quality control inspections and prepared work areas for the next day. There were no breaks in production. When workers clocked out, new workers clocked in and picked up exactly where the previous shift had stopped. Supply chain logistics were staggering. A single B-29 required over 40,000 individual parts, sourced from more than 60 subcontractors across the United States. Engine components came from Wright Aeronautical in Ohio. Propellers came from SOES. Curtiss-Wright. Landing gear came from Cleveland Pneumatic. Electrical systems came from General Electric. Radio equipment came from dozens of electronics manufacturers. Every part had to arrive at the assembly plant exactly when needed, too early, and parts accumulated in warehouses, tying up capital and space. Too late, and assembly lines stopped, costing time and money. Boeing developed sophisticated inventory management systems to track thousands of components moving through the supply chain. Railroad schedules were coordinated to deliver parts just in time for assembly. The entire system represented a level of industrial organization that had never been attempted for military production. And it worked. By mid-1944, American factories were producing B-29 seconds faster than the Army Air Forces could train crews to fly them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Training B-29 crews was itself a massive undertaking. Each aircraft required 11 crew members: aircraft commander, pilot, bombardier, navigator, flight engineer, radio operator, radar operator, and 4 gunners. Every crew member needed specialized training. Pilots trained for months to master the complex 4-engine bomber. Bombardiers learned to operate the sophisticated Norden bomb sight and radar bombing systems. Gunners trained on the remote-controlled turret systems. The Army Air Forces established specialized B-29 training bases across the United States: Walker Army Airfield in Kansas, Pratt Army Airfield in Kansas, Great Bend Army Airfield in Kansas, multiple facilities in Kansas because of the state's proximity to Boeing's Wichita plant. Crews trained for months before deploying overseas. The training consumed resources and time, but cutting corners would cost lives in combat. By the time the first B-29 seconds arrived in theater in early 1944, crews had hundreds of hours of training. They understood the aircraft systems, its capabilities, its limitations. They knew the engines ran hot and required constant monitoring. They knew the pressurization system was temperamental. They knew the remote gun turrets sometimes malfunctioned. But they also knew they were flying the most advanced bomber in the world. The cost of this entire program was staggering. Development costs exceeded $9 million. Production costs for 3,970 aircraft totaled $3.7 billion. That was an average of $930,000 per aircraft. For comparison, a B-17 Flying Fortress cost approximately $210,000. A B-24 Liberator cost about $300,000. The B-29 cost more than 4 times as much as a B-17. $3 billion. The Manhattan Project, which developed the atomic bombs, cost $2 billion. The B-29 program cost 50% more than building the atomic bomb. It was the single most expensive military project of World War II, more expensive than any naval construction program, more expensive than any weapons development, more expensive than anything. And that cost was before operational expenses. Each B-29 required 46 people to operate and maintain. After 4,000 flight hours, each aircraft needed depot-level overhaul and modification costing $99,000. Spare parts, maintenance equipment, ground support vehicles, fuel trucks, bomb hoists, everything required to keep B-29 seconds operational added billions more to the total program cost. Critics in Congress questioned whether the investment was worthwhile. $3 billion was an almost incomprehensible sum in 1944. That money could have built thousands of conventional bombers. It could have built hundreds of ships. It could have equipped dozens of army divisions. Was one advanced bomber worth that much? General Arnold's answer was unequivocal. Yes, because the B-29 could do things no other aircraft could do. It could strike Japan from bases in China, India, and later the Marianas. It could fly higher than Japanese fighters could effectively intercept. It could carry bomb loads that would devastate Japanese industrial capacity. And most importantly, it could deliver the atomic bombs that would end the war. Only the B-29 had the range, the payload capacity, and the pressurized bomb bay needed to carry and deploy atomic weapons. The specially modified B-29 seconds designated Silver Plate aircraft underwent extensive modifications to carry nuclear weapons, but the basic airframe was the only bomber capable of the mission. Without the B-29, the Manhattan Project would have produced bombs with no way to deliver them. But in March 1945, the atomic bombs were still theoretical. The immediate mission was firebombing Japanese cities, and for that mission, the B-29 proved devastatingly effective. The combination of high bomb load, long range, and advanced navigation systems meant B-29 seconds could strike any target in Japan with precision and overwhelming force. After Operation Meeting House, on March 9th through 10th, destroyed 16 square miles of Tokyo, General LeMay immediately planned follow-up raids. Osaka, on March 13th, 124 B-29 seconds burning 3 square miles of the city. Kobe, on March 16th, 331 B-29 seconds destroying 3 square miles. Nagoya, on March 19th, 290 B-29 seconds burning 3 square miles, the pattern repeated across Japan. Every few days, hundreds of B-29 seconds appeared over a Japanese city, dropped thousands of tons of incendiaries, and created a firestorm. Japanese air defenses shot down aircraft. Anti-aircraft fire damaged dozens more. But the losses were sustainable. A 5% loss rate meant 95% of the bomber force returned safely, and American factories replaced losses within days. By May 1945, Japanese cities were running out of targets. 66 major urban areas had been bombed. 25 million people had been displaced from their homes. Japanese war production had declined by 60%. Factories couldn't operate without workers. Workers couldn't work without homes. The strategic bombing campaign was systematically dismantling Japan's capacity to continue the war. Japanese military planners understood they were facing an enemy they couldn't defeat through military means. American industrial capacity was simply too large. Every metric favored the United States by ratios that made victory impossible. Steel production, aircraft production, shipbuilding, petroleum refining, electrical generating capacity, every measure of industrial strength was dominated by American output. Japan produced 8.4 million tons of steel in 1943, declining to 6 million tons in 1944. The United States produced 80 million tons in 1944. The steel gap was more than 10 to 1. That steel went into ships, aircraft, tanks, vehicles, weapons, everything. Japan produced 76,000 aircraft during the entire war. The United States produced 300,000 military aircraft, nearly 4 to 1. And American aircraft were generally more advanced, better armed, more reliable. A numerical advantage multiplied by a qualitative advantage. Japan's total military production in 1944 was valued at approximately $6 billion. United States military production in 1944 exceeded $85 billion, more than 14 times larger. Germany and Japan combined produced less than the United States alone. These numbers weren't abstract statistics. They translated directly into combat power. When 300 B-29 seconds appeared over a Japanese city, they represented $300 million of aircraft, thousands of trained crew members, tens of thousands of tons of bombs, and the industrial capacity of an entire nation mobilized for total war. Japanese fighters could shoot down 10 B-29 seconds, 20 B-29 seconds, even 50 B-29 seconds. It didn't matter. More would arrive next week because American factories were producing 170 B-29 seconds per month. The production pipeline was so large that combat losses were irrelevant to overall force strength. By June 1945, the strategic situation was hopeless for Japan. The Imperial Navy had been destroyed at Leyte Gulf and in dozens of smaller engagements. Japanese merchant shipping had been decimated by American submarines and air attacks. Food imports had stopped. Oil imports had stopped. Industrial raw materials were no longer reaching Japanese factories. The home islands were under naval blockade and air bombardment. On July 16, 1945, the first atomic bomb was successfully tested in New Mexico. President Harry Truman, informed of the test while attending the Potsdam Conference in Germany, understood immediately what this meant. The war could be ended without invading Japan. B-29 seconds could deliver atomic weapons directly to Japanese cities. Two specially modified silverplate B-29 seconds were prepared for atomic missions. Enola Gay, commanded by Colonel Paul Tibbets, would carry the uranium bomb designated Little Boy. Boxcar, commanded by Major Charles Sweeney, would carry the plutonium bomb designated Fat Man. Both aircraft underwent extensive modifications. The bomb bay was reconfigured. Special release mechanisms were installed. Engines were blueprinted for maximum reliability. Every system was tested repeatedly. On August 6, 1945, at 08:15 local time, Enola Gay released Little Boy over Hiroshima from an altitude of 31,600 feet. The uranium bomb detonated at 1,940 feet above the city, with a yield equivalent to 15,000 tons of TNT. The explosion destroyed 5 square miles of Hiroshima's urban area. 60 to 80,000 people died immediately. Tens of thousands more would die from radiation exposure in the following weeks and months. 3 days later, on August 9th, Boxcar released Fat Man over Nagasaki from 28,900 feet. The plutonium bomb detonated at 1,640 feet with a yield equivalent to 21,000 tons of TNT. The explosion destroyed roughly 2.6 square miles of Nagasaki. Approximately 40,000 people died immediately. Japan surrendered on August 15, 1945. Emperor Hirohito announced the surrender in a radio broadcast, citing a new and most cruel bomb as one reason for accepting the Potsdam Declaration's terms. The atomic bombs ended the war, but they were delivered by B-29 Superfortresses, aircraft that represented the culmination of America's industrial mobilization. In the end, the Japanese had been correct about one thing. The B-29 was impossibly complex, incredibly expensive, and extraordinarily difficult to produce. What they failed to understand was that American industry could do impossible things. $3 billion, 4,000 aircraft. The B-29 program demonstrated that industrial capacity, not martial valor or tactical brilliance, would determine the outcome of modern industrial warfare. Japan entered the war with superior carrier aviation, experienced pilots, and decades of military tradition. They lost to an enemy who could build bombers faster than Japan could shoot them down. When Japanese intelligence estimated that America could produce a maximum of 200 B-29 seconds, they were applying Japanese manufacturing assumptions to American industrial capacity. Those assumptions were wrong. America didn't build aircraft the way Japan built aircraft. America industrialized bomber production using assembly line methods, standardized components, and massive workforces trained for specific tasks. The result was production on a scale Japan couldn't comprehend until it was too late. By the time Japanese planners realized American B-29 strength exceeded 1,000 aircraft, those aircraft were systematically destroying Japanese cities, and there was no defense that could stop them. The lesson extended beyond World War II. The nation that controlled industrial production would dominate military conflicts. Courage mattered, training mattered, tactics mattered, but production capacity mattered more. An enemy who could replace losses faster than you could inflict them would eventually win through simple arithmetic. Japan lost that arithmetic contest by margins that doomed them from the moment they attacked Pearl Harbor. Admiral Isoroku Yamamoto, who had lived in America and understood American industrial capacity, warned Japanese leaders before the war. He said Japan could win battles for 6 months, perhaps a 2-year. After that, American production would overwhelm anything Japan could field. Yamamoto was correct. Japan won battles for 6 months. Then American industry mobilized, and the production advantage became insurmountable. The B-29 was simply the most visible symbol of that advantage. An aircraft so advanced it shouldn't have been possible, produced in numbers so large they seemed fantastical, deployed with logistics so sophisticated they redefined strategic bombing. When the last B-29 rolled off Boeing's Wichita production line on October 10, 1945, Total production stood at 3,970 aircraft, 20 times the number Japanese intelligence had estimated as America's maximum possible production. The estimation error wasn't a small miscalculation. It was a fundamental misunderstanding of what American industrial capacity could achieve when fully mobilized. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.